Hi friends, in this video I'm going to talk about the structure of glucose, and before I start I'm going to explain some points in this video that has to do with the pyranose and furanose. I'm going to talk about it in details in this video, and as well I'm going to talk about the hemiacetal, and also I'll talk about the hemiketal, right? Then at the same time I'm going to talk about the outward projection formula, and also I'm going to talk about the Fisher projection formula. So that's actually what I'm going to be talking about in this video. That simply means I'm going to be focusing on this aspect: the pyranose and the furanose form, the formation of hemiacetal, and also what hemiketal. Hemiacetal, it should be here, and also hemiketal. Then outwards and also what Fisher projection formula. That's what I'm going to be focusing on in this video. Now, so let's go ahead. First thing, for a better understanding of glucose structure, then I'm going to draw a structure out. The normal structure of glucose, we know it to be C double bond O here. We are going to have hydrogen here. We're going to have carbon here. Carbon is here. Carbon is here. Carbon is here. And last carbon is here as well. Then the carbon here has hydroxy group here. And also we have hydrogen here. And also what? Hydrogen here. Then here I'm having OH group here. Right? And also I'm having an hydroxy group here on carbon number 2. Then on carbon number 3 I'm having an hydroxy group here, right? Then I'm having an hydrogen group here, right? Then on carbon number 4 I'm having hydroxy group here. Then I'm having OH group here as well. Then on carbon number 5 I'm having what? OH group here, and also what? I'm having what? Hydrogen here. So this is the normal structure for D-glucose. D-glucose. The normal structure for D-glucose is this. Now from there now, we just have to consider something here. The formation of hemiketal and also hemiacetal is actually what I'm going to be explaining first, right? So we actually know that okay, monosaccharides actually have two functional groups, in which the first functional group is known as the aldehyde, and the second functional group is known as what? As ketone. So the real and the in-depth explanation behind acetal or ketal is this. Now, whenever you have acetal, from the word aldehyde, aldehyde, you know, something like, I know you guys have heard about acetyl, acetal, whenever it's ending with al, it's actually what? Aldehyde. Now, whenever an aldehyde functional group, which is C double bond O, then we have OH here, right? Whenever it reacts with alcohol, then we are going to be having the formation of hemiacetal. That is, whenever we have aldehyde reacting with alcohol, we have what? Hemiacetal. Then whenever we have ketone or simply ketone reacting with what? With alcohol, we call this hemiketal. Right? So in order for us to understand the structure of glucose and also other monosaccharides, that is the projection formula that we have, you have to understand what hemiacetal means and also what hemiketal means, right? And also at the same time, I'm going to be explaining. Okay, I think I've explained what D-glucose is and also what L-glucose is. I think that's also what we need. Then from there, I'm going to explain more better on alpha and also what beta glucose. That is the anomers of glucose that we have. Now from there now, since we successfully established that whenever aldehyde reacts with alcohol, we call this what? Hemiacetal. That is, an acetal group is formed. Whenever ketone group reacts with alcohol, then hemiketal is what? Is formed. Then from there now, let's actually see the reactions. Let's see the reaction. Now from here, this is D-glucose, right? And this is carbon number 1, carbon number 2, carbon number 3, 4, 5, 6 of glucose, right? Now, one thing I want you guys to understand is that the terminal carbon is actually the what? The terminal carbon is the one that is found in what? In carbon number 5. This is the terminal carbon. So that shows that here is the terminal alcohol, right? Here is the terminal alcohol. So now this is basically what is going to be happen. What will happen? Hemiacetal is formed when carbon number 1 of glucose molecule reacts with what? With the hydroxy group, right? On carbon number 5. And that shows that this is the terminal what? Terminal hydroxy group. Whenever the carbon number 1 of glucose molecule reacts with what? With the terminal alcohol or carbon number 5, that shows that we are producing what? Hemiacetal. And in this case, what I'm basically saying is that the carbon number 1 here has functional group of what? Of aldehyde. So the reaction actually occur between aldehyde and also what? Hydroxy group. So whenever the reaction occur between aldehyde and also what? Hydroxy group, we are going to have what? Hemiacetal. Right? Then from there, I'm going to redraw the structure of this molecule very well, because we actually remove what? A molecule of what? Of water. So from there, redrawing it in the hemiacetal form, I'm going to have this to be C. We are going to have OH here. We're going to have OH here, right? I'm going to have carbon is here, connected to what? OH, right? That is the hemiacetal group. I'm going to have hydrogen here as well. Then let's go ahead and fill the rest with carbon, right? So here I'm going to have CH2OH. Everything here, CH2OH. I've turned it to CH2OH. Then the next one, I'm going to have hydrogen at this side. Then I'm going to have hydroxy group at this side, right? Then I'm going to have another hydrogen group here, right? I'm going to have hydroxy group on this side on carbon number 3. Then I'm going to have hydrogen here. Then this side as well, I'm going to have hydrogen here, right? Where I'm going to have hydroxy group here. So now look at this. So the hydroxy group here is an alcohol, right? Is OH. But one thing is that in the formation of what? Of hemiacetal, the hydroxy group that was supposed to be on this carbon number 5 has actually taken part in what? In the reaction. And in that scenario, what it simply means that there is a bond. A bond here is actually what? Is a bond. There's a bond here that actually shows the what? The interaction between what? Between this oxygen and also what? This carbon here, right? So in that case, carbon number 1 of what? Of glucose reacts with what? Carbon number 5 of what? Of glucose to form some what we called hemiacetal. And what is found on carbon number 1 is actually what? Aldehyde and hydroxy group. Aldehyde reacts to hydroxy group to form what? To form hemiacetal. In this case, this is what? Hemiacetal, and it is mostly referred to as what? As alpha D glucose. This is alpha D glucose. I'm going to explain the reason why I call it alpha D glucose. And in my last video, I actually explained what is alpha and also what? Beta. What they actually mean. Alpha and beta are actually what? Anomers of each other. They are found and they occur based on the orientation of this hydroxy group that is positioned on what? On carbon number 1. Now, if this hydroxy group is on this side, on this right side, you call it what? Alpha, right? Then if it is on this side, you call it what? Beta. For example, let's see the case of another structure here. Let's say we have another structure let's say we have another structure here. Let's say you have another structure here. Now, here, let's say the structure that we have here is actually, we have a carbon here. Then here we have what? Hydrogen here. We have hydrogen here. Carbon is here. Then we have the hydrogen is here. Then we have hydroxide group here, right? Then let's just say we have carbon here. Furthermore, we have what? We have hydrogen here. We have carbon here. Hydrogen is here. Then OH is going to be on this side, right? Here as well, we have what? OH is here. Then we have what? Hydrogen is here, right? Then here we are going to have carbon is here. We have hydrogen to fill this side. Then here is CH2OH. Now look at this. Look at this carbon number 1. this carbon number 1 actually has its what OH on this side. In that case, it is referred to as what? As beta D glucose. Right? While those ones that have the hydroxyl group on what? On this left hand side, they're on this right hand side, are referred to as what? As alpha D glucose. Can you see it now? So don't forget that a bond actually is drawn out here that connected what? The carbon number 1 and also what? Carbon number 5 together. And that's just it. So that's just it. As far as the hemiacetal and also what? Hemiacetal is concerned. Now, in the case of hemiketal, I'm going to explain it further here. I'm going to explain it further in this video. But let's see the cyclic form, because this actually was the Fischer projection formula. That is the projection formula as far as Fischer is concerned. This is it. Now, let's see the outward form of glucose now. The outward projection formula of what? Of glucose. Now, let's say we have our diagram here, right? The outward behavior formula is actually based on what? On that's 6 carbon atom, cyclic 6 carbon atom, which is based on pyranose, right? So this actually we are going to have OH on this side, right? We are going to have hydrogen on this side. Then we are going to have OH on this side. We are going to have hydrogen on this side, right? Then here we are going to have hydrogen on this side. We are going to have OH on this side. So here as well, we are going to have OH on this side. Then we are going to have hydrogen on this side. Then here as well, we are going to have hydrogen to be here. We are going to have CH2. We are going to have OH. Now this is the pyranose form, or simply let me just say the outward projection formula for glucose.